Hi, today we're going to begin using our skills of factoring and solving for x to help us see why we do this. So let's put our name at the top of the paper so that what is yours never gets lost. And what we find is that the reason that we factor these equations, the reasons that we solve for x, is so that we can go and then find the possible locations of where a quadratic is going to cross the x-axis. That's our goal. So let's have a brief discussion looking at our calculator of what graphs can look like to begin with. So we have here the standard form of a quadratic. That's great. And we're going to solve it by graphing. First off, remember, solving is to find your x-intercepts. Let's write that. That's what we're trying to do, is find the x-intercepts. So with any luck, we'll spend a lot of time saying, right there, look at it, it's right there, that's where it crosses. Because we're graphing, which is nice. So let's turn on your graphing calculator. And remember, we are always going to start on a totally new document, never saving. And let's graph. And our first equation, as told to us on the handout, is x squared minus 1. We push enter, and there it is. You should have that graph on your screen, and if you can't get that, oh, you need to come and talk to me real fast. Okay, so looking at this graph, how many x-intercepts, how many solutions does it have? And you'd say, well, they're right there. And I'd say, where? And you'd say, right there. 2 of them. And I'd say, good. That's exactly right. So let's go build the table, Control T, so that we can plot our points. Okay, we see points are now repeating. That's super. So I can't plot 15 units. That's not going to fit. But I can plot 8 units. So let's begin plotting our points. To the left, 3. 1, 2, 3, up 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our first point. Second point, left 2, up 3. 1, 2, 3. Third point, left 1, up nothing. Fourth point, over nothing, down 1. Fifth point, right 1, up nothing. Sixth point, right 2, up 3. 1, 2, 3. And finally, our 7th and last point, right 3, up 8. And again, we see, it's been a while, but we see this beautiful symmetry of how my points match each other on the left and right of the axis of symmetry. Remember that word? The axis of symmetry. So, how many solutions do I have? 2 of them. Where are they located? Right there. So what is the address, what is the coordinate point of the one on the left? It was -1, 0. What is the address or the coordinate point of the solution on the right? 1, 0. There you go. How many solutions did we get? 2 of them. Ta-da! And they are 2 real solutions. So the reason we bring up the real aspect is because in mathematics, yeah, there are real numbers and there are imaginary numbers. Just like when you were little, you had real friends and you probably had imaginary friends. And those imaginary friends were very powerful to you, even though your parents probably didn't get it. And that's standard, that's normal. So here, real numbers are very powerful, but also imaginary numbers can be very powerful. And imaginary numbers are different from negative numbers. So we're going to bump into some of those today. All right, so let's look at our second graph. Our second graph is the parent function of all quadratics. We'll even write that down just to help re-emphasize for our own brains. Parent function Let's get out your handy-dandy calculator and open a new page. Control Doc, Graph, and our function is just x squared. So your graph should look just like that one. And if it doesn't, let me know. Let's go look at the table. Control T. There's the table. And my points will fit on my graph starting at -3, 9. So that's where we'll begin plotting them. So to the left 3, up 9. Next point, left 2, up 4. 2, 3, 4. Third point, left 1, up 1. Fourth point, dead center on the origin. Fifth point, right 1, up 1. Sixth point, right 2, up 4. Seventh point, right 3, up 9. Again, we have our beautiful symmetry. Everything matches. Boy, that feels good to know that we're doing something right because everything matched. Okay, so again, I would say, hey, you got any solutions? And you'd say, yep, I do. And I would say, how do you know? And you'd say, because I see it right there. And I'd say, that's right, good job. So this is your solution. It happens to be located at the coordinate point of 0, 0. It is at the origin. How many solutions, how many times did this particular quadratic touch or cross the x-axis? One real solution. It really happened just one time. All right, so let's check it out for one more graph. So here again, Control Doc, go get a graph. And this particular equation is going to be x squared plus 1. There's your graph. Let's go push Control T to look at my table. And the highest my points will fit is -3, 10. So let's start with that. Left 3, up 10. Left 2, up 5. 1, 2, 3, 4, 5. Left 1, up 2. Over nothing, up 1. Right 1, up 2. Right 2, up 5. Right 3, up 10. All right. So here we are, and I would continue with the same question of, so tell me about your solutions. And you'd say, what? And I'd say, how many times does this particular quadratic touch or cross the x-axis? And you'd say, well, it touches and crosses the y-axis. I'd say, yeah, but I'm not asking about that. I want the x-axis, this guy right here. And you'd say, it ain't got none. And I'd say, you're right. So this has 0 real solutions. If you wanted to be super technical, you might say that it has a couple of imaginary solutions, but we're not going to do those just yet. We'll do those on a different lesson. So, well, maybe later on in this lesson. All right? So this does not cross or touch the x-axis at all. So we can refer to these solutions. What are the other names of solutions? Do you remember the 3 other names? Because depending on who wrote the question, whether it be a worksheet or their state test, there are 3 other names they could use. Zeros, roots, x-intercepts. Great. So we've seen that you could have a variety of options. And you can also have a variety of what they're called. Incidentally, this might also give you the word none. So if it asks for the number of solutions, you might write the word none. If it says, what is the solution? Writing the word none. The number of solutions could also be the number 0. But if it says, what is the solution? This is not 0 because the solution does not happen right there at the origin. So you need to be careful with your semantics and the vocabulary that they use in the question, and just really being attentive to the grammar and exactly what's asked of you. All right, so our first big example says solve using the calculator. Make sure that the equation is equal to 0. Let's underline this. This is a big deal. Your equations must be equal to 0 to do this. And if they're not, you must get them there. Yes, that's crucial. So it's not a hard thing. You just have to add or subtract across the x-axis. You just have to make sure that you do it. So now we're going to practice using our calculator skills. We can do this a couple of different ways. So let's get a new page. Control Doc. Let's get a graph. And let's type this in. X squared minus 6x plus 3. So in this particular graph, I do have 2 solutions. That's very clear. 1, 2. Right there. 1, 2. Great, but they don't cross at a nice clean integer value. So we'll write 2 solutions, 2 real solutions. But to go find them, we need to do some options in the programming in your calculator if we're going to use the graph. So to do this, you're going to push Menu, you're going to push 6, which is Analyze. Analyze your graph. And then it gives you options of what do you want to go find. And you'd say, number 1, I want the 0. So when you push that, things are going to blink and you're going to get a nice dotted line in the center. So we're going to put the dotted line in the center of the quadratic. Push enter. You're going to slide, which will cause it to shade right and left. Using your mouse. Okay, so let's practice this. Let's see how to do this. So I'm going to have to put the calculator on the screen, and you're going to have your instructions right beside your paper as we do this together. All right. So we push Menu, and then 6 for Analyze, and 1 for 0. And see, here is my dotted line, and I'm going to slide that over to the center of my curve. It doesn't have to be exactly centered, but somewhere there in the center, and push enter. And now when you slide to the right, it shades up, and see this coordinate point appeared. Check it out. So we're going to write that down on your paper. So we're going to say 5.45, comma 0. That is one of the solutions for that particular graph. Now let's slide to the left. And check it out. There's another coordinate point that showed up on your screen. So this is the point 0.551, comma 0. Writing that on your paper. These are my two solutions we have solved. So there are a handful of ways to do this on your graphing calculator, but I think that's a pretty great one as far as being able to see it and know that you're doing things accurately, correctly. Okay? All right, let's turn the page. All right. So these first examples, they want us to solve them. We're going to go find the x-intercepts, not using a graph, but we're going to just take the square root. How do we do that? Well, using just basic algebra skills of solving for x. So good old-fashioned equation. Draw the river. I need to get x alone and positive. So how do I get rid of the 9? Yeah, you know, add 9 to both sides. It's been a minute since we've done this, hasn't it? But it's like, oh, score. Just like real numbers for a minute? Yep, nice clean numbers. X squared equals 0 plus 9 is 9. Yeah. So this square, how do you get rid of that? What's the opposite of a square? It's a square root. And remember, what you do to one side of the river, yeah, you do to the other. There's a catch. I've left space here. If you take the square root of a legit number, there has to be an acknowledgement that that could have come from either a positive or a negative number. We're going to talk about that in just a moment. So this square root and this square cancel out on the left, leaving you with x equals positive and negative. What's the square root of 9? 3. Done. So this particular quadratic will cross the x-axis at positive 3 and at negative 3. So let's find out what's going on real quick with this plus and minus business. So if I had wanted to create, this is a positive 9. Positive 9 could have come from a positive 3 times a positive 3. Yeah, that makes positive 9. Or it could have come from a negative 3 times a negative 3 to make a positive 9. And we are acknowledging both situations with this plus and minus. So it's either both positives, both negatives. So if you were to graph this, what you would find is something like that. Okay? So to finish this off, we would say, hey, this has 2 real solutions. And they are located at positive and negative 3. Awesome.